Good morning. Sorry for the delay. Are everyone here from CFAL itself?
Yeah, sir.
Yes, sir.
Anybody from 7th standard?
Yes, sir.
Yes, sir.
Yes.
A lot of you from 7th standard as well. Fine. Okay. Then we'll do something like let the 7th standard first reply, because I think some of the portions would be done for 8th standard, right? So you would have an advantage anyways. So let the 7th standard students try. Let them answer. Then obviously we can see whether if they're not able to answer it, probably you people can take it up. Okay, let me just. Okay, today, just 1 minute, we are going to stream this as well. Just going to cross check. Okay, so we're going to start with the number system, right? So for your NMTC exam, 50% of your portion, 50% of the questions that come from this chapter, right? So what exactly are number system, or what exactly are numbers? So we use this in our daily life, right? Numbers, counting numbers like 1, 2, 3, 4, so on, and probably for purchasing, some calculation for our marks, lot of things, right? So while doing this, sometimes probably you have noticed something like multiplying with 5 will always end up with a 5 or 0. So all these properties come under number system, right? So the simplest example would be, say suppose there's some number like a, right? Whenever I multiply with 10, one thing I already know that the last digit is 0, correct? This is pretty obvious, right? So one of the properties you can say of number system, right? So let me just add a screen here. Okay, it's in different form. Okay, anyways. So what are these numbers, right? So first, I think the number system which you would have learned is called as natural numbers, right? So in natural numbers, we have counting numbers 1, 2, 3, 4, so on. I hope everybody knows this, right? After that, probably you added 0 to this number system, correct? Natural numbers. You call this as counting numbers as well, right? So you call it as whole number, and it's starting from 0 again, 1, 2, 3, right? So on. The next comes integers, right? Denoted by the letter, capital letter Z. So anybody can answer what are integers? 7th standard students.
Yes, sir.
Yes, Varshini.
Sir, integers include the whole numbers along with the negative numbers like -1, -2 until infinity.
Yes. So for it comes from the negative side, right? Again, we are including negative numbers like -4, -3. So -2, -1. Then we have 0. Then we have 1, 2, 3. Again, it extends to the other side. So what we are saying is all these are infinite. All these are infinite. So we are coming from negative minus infinity, right? All the numbers and going to positive infinity, right? So this is what our main systems are: natural numbers, whole numbers, and integers. What next? What next? What else do we know?
We have other numbers like fractions, decimals.
Okay, fractions, decimals. Okay, what can we club fractions and decimals into? I have a doubt. I have a doubt, Varshini. Can you clear my doubt? Is 5 by 4? This is a fraction, right? 5 by 4 is a fraction, correct?
Yes, sir.
What about 1.25? Is it a decimal?
It
1.25?
is, it is a decimal number, sir. It is a number which contains a decimal.
Yeah. So what about, are these two numbers different? 5 by 4 and 1.25?
No, sir. If you actually divide 5 by 4, you get the same 1.2.
Okay. Fine. So this is just represented in a fraction, and this is represented in a decimal format, something like that, right?
Yes, sir.
Okay. So do we have any number system so that we can club all these numbers? Because see, these two are the same thing, as you said, right? So we want some system which will cover all these fractions and decimals and so on. Do we have something like that?
Rational number.
Rational numbers.
Rational numbers. Okay. What letter do we use for rational numbers? Any idea?
Q.
Q. Okay. We use the letter Q. So what exactly comes under rational numbers? I just agreed with you, but I'm not sure.
A rational number.
Give me some examples. We'll just note it down, then we'll see the difference. Any example here?
3 by 5, negative 4.
Negative 2. Negative 2 is also a rational number. Then
Negative 3 by 9.
negative 3 by 9. Okay, if you simplify, it's negative 1 by 3. Okay.
Yeah, it's the same.
Something positive?
0.
0 also is there. Okay.
5.35.
5.35. Okay, nice.
Pi. Oh, no, not pi. I'm sorry, not pi.
Not pi. Okay.
Pi is
Okay, we have enough examples, I think. We have enough examples. So, can you tell me what is the criteria here? How did you write all these numbers?
It is any number p by q in where p is and q are integers and q is not equal to 0.
Okay, any number that can be written in this form, p by q, where p and q belong to integers, is 0. Correct. So, if these are the conditions, right, and we write p by q, then what we get is a rational number, right? Therefore, if you see that if p can be 0, q cannot be 0, so numerator can be 0 and denominator is 2, I'm going to get 0, still a rational number, right? An integer 2, still a rational number, because 2 divided by 1, right? Both are integers, can be written in this form. Is it fine? Everybody agrees what rational numbers are, right? So any example, basically, when you're writing decimal, you have to be a bit careful, right? It should end, that's all. Then we can represent it in.
Sure.
How do I represent 5.3? Yes?
No, even like it need not necessarily end. Even recurring decimals can
Yes.
be termed as rational numbers.
Yeah, exactly. But first, let's see about 5.35. Is there any, can I represent it in P by Q? If I cannot represent like this, our definition fails, right?
Sir, we can represent 535 by 100.
Okay, 535 by 100. Great.
Yes.
535 by 100. So when the decimal ends, it's very easy to, right? What you have to do? Multiply by so many hundreds or so many zeros in the numerator and denominator. When I'm saying zeros, I mean 1 and zeros. Okay. So if it is, say, 5.2345, I'll multiply with 10 power 4, right? Just to make the numerator, a number, right? Say an integer, right? Denominator is any of an integer. I'm multiplying with the integer, right? So that's the idea. Now, I told you the decimal should end, right? This is the reason. because it's easy to do that. What if the decimal doesn't end? What is it if it is 1.33333? Keeps on getting.
Irrational, sir.
Irrational? Okay.
It is rational. It can be converted into a fraction.
Yes. What is it, Abhi? Abhi?
It can be converted into a fraction.
It can't be, or it can be.
It can.
It can. Oh, can you tell me what that fraction is?
It is 4/3.
4/3. Others, if you want, you can check what is 4/3. If I divide.
3.
Yes, correct.
But it's approximation, sir.
Approximation. Why?
No, sir, like it's
No.
Not approximation. When we divide
1.33.
exactly.
Yes, it's not approximation. Exactly what I've written down, right? I'm not saying it's 1.3. I'm not stopping there. Correct. I'm saying it is continuously 1.33. It keeps on going up to infinity. Why is an approximation? No. So how do you figure out? No, what is this? If the decimal ends, we are saying it's rational. I mean, the numbers end, right? We are saying it's a rational. If they do not end also, we are saying it's rational. Then what is there any?
Yes, sir. Like example, the value of pi is irrational where the numbers they don't recur, but every time they go on changing. Like pi, it goes on 3.142 so on.
So what you're saying is, after say any number, say 2, 3, 4, 8, 6, 2, 5, 6, 3, 2, so on. If there is no pattern, if it doesn't repeat or doesn't recur, you're saying it's irrational. That's what you're saying?
Yes, sir.
Okay.
And if it goes on?
Yeah, it goes on and it doesn't repeat, right? So this is irrational. Everybody agrees with this?
Yes.
Yes? Everybody agrees? My other question is, suppose my number is say 2.2348. Now this repeats. 2348 repeats. Okay, that's fine.
Yes.
So is it rational or irrational now?
It is rational.
Rational?
Yes.
Sure.
Yes.
Okay, can you tell me how to convert this then?
Okay, I know a method. If you call that x,
Okay, if I call this as a x.
then right now, yeah, and you have 1000 x's. 2348.234823.
1000, I think 10 power 4, right? 10,000x.
Yes.
This
1,
is
2,
what you
3.
want,
Yeah,
right?
sorry, 10,000. Yeah.
Yeah.
It's 22348.
Okay. Dot again, it repeats, right?
Yes. So now, if you subtract the first thing from the second thing from the first thing from the second thing, that's 10,000x minus x.
Just let me write it down clearly. Let me see if I can. If I add a page. Just 1 second. Okay, we'll just change the color here itself. It's not ideal, but still. Okay, so we had our number was 2.2348, if I'm not wrong, correct?
Yes.
So you're suggesting to take this as x, correct? And it was repeating 2348. This is what I said. Our concern was, if I take 2348, can I write in the form of P by Q? Because that is our definition. That's all we all agreed, right?
Yes.
So if I can't write in the form P by Q, probably it may not be a rational number. That's why I want to check. Is it fine? So then we multiply with 10 power 4. Now, why did we multiply with 10 power 4? Because the repeating numbers were 4 digits, right? That's the reason. Okay. So once we multiply, we're going to get 2, 2, 3, 4, 8, 4, 8, 2, 3, 4, 8, so on. Yes, what next?
Then we subtract the 10 power 4x minus x. So the tail cancels and we get two numbers.
So second equation minus first. Right? So what I'm
Yes.
getting on the left hand side is
9x
yeah. Okay. On the right hand
is equal to 2, 2, 3, 4, 6.
see the important point here is the decimal part will get cancelled out. Can you see that? Right? Because it's the same thing. Entire decimal part is the same thing. It will get cancelled out. That's the trick here. That's why we do this. We multiply with what part is recurring. Okay. What will happen is, see, this part will get shifted, right, to the other side of the decimal. But if you see the remaining part is still the same. So when I subtract, this entire decimal part will go off. I hope you can see that. Now when I simply subtract, this is what? 2, 2, 3, 4, instead of 8 minus 2, which is 6. Can you see that we have represented this in a fraction now? Right? This is your fraction.
Yes.
Okay. So any what example I take of a fraction, sorry, of a decimal which is recurring, right? Recurring, I can always convert it into a fraction. So it's always a rational number. Is it fine? So do we know the clear difference between rational and irrational now? So for irrational numbers,
Yes.
usually they don't have a particular letter, right? What they do is they just strike off this Q just to show it's irrational. Okay. So any number which is not rational is irrational. Do you agree?
Yes.
Yes? Everybody agrees?
Yes, sir.
Or are there any other numbers which are not neither rational nor irrational? Yes, Saket?
So complex numbers.
Complex, okay. We are today we'll stick to real domain, right? We're not going to go into complex numbers, right? The majority of our problems when you are solving, right, we're only sticking to real numbers. This is because if you go to complex number, a lot of properties we cannot use, and in a real life situations, we generally use only real numbers. So we'll stick to that for now. In higher classes, we'll learn about complex numbers. Okay. Fine. So this is true. So a set of real numbers, okay, real numbers is the final set. What you have represented with the letter capital R, right? So real numbers is nothing but the combination of your rational and irrational numbers. Okay. So any number is either rational or irrational, and the combination of that set is called real numbers. Is it fine?
Yes, sir.
Yes. So
Yes, sir.
in this chapter, number system, mainly we are looking at natural numbers or integers, right? We are interested in factors, multiples, and so on, right? Based on those, we'll see some properties and we'll try to solve few problems. Okay. So I won't go into the theory part or entire theory part at least. We'll take up some problems. While solving that, what is required, we'll discuss there. Okay. So majority of these problems, even without the knowledge or without the theory part, you can solve because you have practiced numbers a lot, right? Okay. Just before getting into that, I just want to see, are we comfortable with even odd numbers? We know what are even odd numbers?
Yes, sir.
Yes. Okay. We know what are prime numbers?
Yes.
Yes.
Yes, sir.
We know what are composite numbers?
Yes,
Yes.
sir.
Okay. Few examples for prime.
2, 3, 5, 7, 11, 13.
19.
Okay. Nobody started with one. Nobody started with one.
No, sir. One is a
No,
unique
sir, one is not
number.
a composite or a prime number.
Okay. One is not a prime. That's all I require. It's not a prime. Everybody agrees. There's no confusion, right? Okay. The
No.
definition of prime number says for numbers greater than 1, right? That's why we don't even check for 1. Okay. So 2, 3, 4, sorry, 2, 3, 5, 7, so on. These are prime numbers. Okay, fine. So we know what are even, odd. We know what are prime numbers. We know what are composite numbers. 4, 8, say 26. All these are composite numbers. If you have more than one factor, not including one, or more than two factors, we call the number composite. Now, what are factors?
Numbers which numbers, for example, the numbers 2 and 4, like the
Remainder is 0,
2
sir.
and 4.
When we divide that number.
When we divide the number, remainder is 0. Nice way to put it, right?
Yes,
So,
sir.
so if I take the number 26, what are the factors?
2 and 13.
2 and 13 only?
2 and 13.
26
And
and 1.
1
1 and 26, 13
1,
and
2, 13 and 26. Okay?
51.
So we say there are 4 factors, right? So 1 and the number is always a factor, right? Any number you take. Okay, if those are the only 2 factors, what you're gonna get is prime, right? If there are more than 2, what you're gonna get is composite. So just for a simple calculation, I want to see how many factors does 8 have? How many factors?
We have 1, 2,
2,
4, 8.
4, 8.
4?
8.
4.
4? Everybody agrees 4 factors? Factors does 25 have?
It has 3 factors.
3? How many factors do 50 have?
50 has
1, 2, 5, and 50.
10.
And 10.
Sure.
10. Then 25 also.
And 10 and
6.
25.
It has 6.
Is
it has
12?
1, 2, it
has
has 1, 2,
25,
5,
10.
10, 25, 50.
It has 6.
How many are there?
It has 6.
6
Yes.
or 8? 6. Sure. Okay. So just to write it down, 1 to 5, 10, 25 and 50. Okay. Fine. So 6 factors. What about 100? What about 100? How many
It
factors?
has 3 factors.
3 factors.
No.
20, 10, 2, 50.
Write it down. You calculate and tell me how many factors.
It has
Right,
9
right.
factors. 9 factors.
9 factors.
9. Sure.
Yes.
Okay. What about others? Let others count. Let's see. Couple of you are saying 9 factors. We'll see if others are getting
Yes,
the same.
sir. Even I think it's
8.
You think it's 9?
Yes.
Sure.
Yes.
No doubts. You have not missed any factors. No.
No,
Okay.
sir.
I'll write down 9 factors. Fine. I'll just increase. Just one more 0 I'll add. Right? 1000. How many factors?
16 factors.
How many?
16.
16. Okay. Anybody else?
I'm sorry, not 16. It's I'm sorry. Yeah, it is 16.
So we have to first factorize it to find the number of factors
Yeah. I know
in
that.
prime numbers.
But I think majority of the students do not know right now. So without using that, I just want them to figure out how many factors does 1000 have, right?
Yeah. 16.
Yeah. Let's wait for others.
Sir, is there an easier way to count factors rather than divide by every number and check?
Yeah. That's what I'm going to show you. What the easier method is. I just want you to see if you can count and figure out. Okay, the answer what you get is 16, right? So just for, I'll just write these things down here. This is 6, right? This is 6. Okay. So what about 12? Smaller numbers we'll see. 12. How many factors?
5.
We have 1, sir, 3,
1, 2, 3,
Six.
4,
There are
6,
6, sir.
6.
and
Good.
12.
6.
Yes, there are 6.
6. Okay. What about number 6 itself? How many factors?
It is 4.
1, 2,
Four, sir.
3, 6.
4, right? Okay.
Yes.
Can you see here some of the numbers were odd, right? Some were odd. So rest are even. Can you? Why are these odd numbers coming? Any idea?
Yes.
Just wait 1 minute. Let others think.
Okay.
Okay, just think about this. Why are there odd numbers in few places and rest all are even, right? Rest all are even. Any particular logic there? If somebody else try to answer. 7th standard students.
So 25 is 3, 56, 100 is 9, it's like 3, 6, 9.
Yeah. Sorry, I couldn't follow. 23? 23 is?
No, sir, like 25, what you have written there, I just told my observation. 25 is 3, and 50 has 6, and 100 is 9, it's like 3, 6, 9.
Oh, okay. Just 1 minute. Can you calculate for 16? Can you calculate for 16? How many factors are there quickly? How many factors for 16?
5.
5. 1, 2, 4, 8, and 16, I think. 5 factors, correct. Again, another odd number. Now, Varshini, does this fit your pattern somehow?
No, sir, now it doesn't.
No, right. So, any other observation can you make apart from?
Because their square numbers 2516.
Yeah, they're square numbers, correct. Why? What's so special about square numbers?
Like 5 repeats. 5 into 5 is 25.
Yes,
Consider
yes.
it once.
Yes. See, these are all perfect squares, correct? So now I am assuming that you know what are perfect squares, correct? So a number multiplied with itself, right? So you can see that
Yes.
this is 5 square, this is 4 square, this is what, 10 square. So any perfect square you take, you're going to get odd number of factors, right? We can see why it is true. What are the factors of 25? 1, 5, and 25. Generally, they come in pairs, right? 1 and 25. But here, number 5 is multiplied with itself.
Yes.
Correct. Therefore, you're going to get only one factor. Any other number you take, 6. See, 6, what are the factors? 1 and 6. 2 and 3. Right? They're in pairs. So all the numbers, the factors come in pairs unless it's a perfect square. In perfect square, one of the number at the center, right, will repeat. So you'll get only one factor there, right? If you want to take, say, 49, right? Factors are 1, 7, and 49, right? So only 7 is repeating, therefore odd number of factors. Just made a note of it. So if you have odd number of factors for a number, it's always a perfect square. Is it okay? Next, some of you were answering this pretty quickly, right? Number of factors, right? So they have a trick how to calculate this. That's why they were answering. You people were writing all the numbers down and calculating, right? What these people were doing is they were writing the prime factors. So do you know prime factorization?
Yes.
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 So what is the prime factorization of, let me say, 100? Sorry, let us take 25 first. Is it 5 into 5? Correct. So prime factor 25 is 5 square. This is how we write, right? So the total factors is equal to 2 plus 1 is 3. I'll tell you what is 2 plus 1 next. Okay. Let's see now for number 100. Number 100, if you write down the factorization, it is 2 square into 5 square.
Yes.
Yes? Okay. 4 into 25. I directly wrote down. If you want, you can use your method of prime factorization and get the answer. Okay. Now, the number of factors is nothing but 2 plus 1 into 2 plus 1, which is 3 into 3, which is 9. Again, I didn't tell you what is 2 plus 1 and all. Right. We'll see. We'll come to that. Simple example, 6. 2 into 3, right? 2 into 3. Right. So it is
Yes.
2 power 1 and 3 power 1. So it is nothing but 1 plus 1 into 1 plus 1. So answer is 4. 4 factors. Can you see all of our answers are matching at least? 6 was 4, 100 was 9, and what? 25 was 3. Correct.
Yes.
Now, did you understand how did I get this 2 plus 1? What
Did
did I
you
do?
multiply like the exponent, its exponent to, I mean, did you add the, like for example, if the exponent is 2 over there, you added 2 plus 1, exponent is 1, you added 1 plus 1.
Yes. That's what I did. So, if my power is 2, I added 1 to it. If there is only a single number there, right? So, total factors became 3. Suppose my power was 2 into 2. So, basically, there were two numbers, both the powers are 2. So, I added 1 to both and multiplied. So, whatever my powers are, I just add 1 to it and multiply. Let me take any number, right? 5 square into 2 into 3. I'm not even going to calculate what the number is. The number of factors will be 2 plus 1 into 1 plus 1 into 1 plus 1. Right? It is 3 into 4, which is 12. So you can check this number if you want. This is what? 25 into 6, 150. So 150 has 12 factors. Is the method clear?
Yes.
Okay. If anybody has a doubt, please ask. Right. Anything is not clear, how to calculate. See, if you start writing down, probably you might miss some factors, correct? This way you won't miss anything. Right? So now you can see why you're getting odd numbers here also. Right? Think about these odd numbers. If it is a perfect square, don't you think this will be a whole square? Always whole square.
It may not be, it might be whole squared into whole squared.
Yeah.
Or power 4 into power 4.
Yeah. That is true. But can you see that is always an even number?
Yes.
That's surely an even number, right? It need not be a single digit. I agree with you. It can be something like this. It can be 5 square into 2 square, right? This is also perfect square.
Yes.
So can you see that if it's an even number, when I add 1 to it, it's an odd number. Correct. And again, an even number, when I add 1 to it, it's an odd number. Always I'll get odd. Right? That's the reason you get odd numbers here. Any other case, if it's not a perfect square, even one extra number is there, like for example, into 3. Now it's not a perfect square. So you're going to get at the end 1 plus 1, an even number. Even one even number is there, the product will be even. Right?
Yes.
Okay. There is a proof for this, right? This is just by, see, what are these numbers? What are these numbers? See, we are just choosing two factors. I don't know if you are able to follow now. I'm just going to give a brief proof here, right? You do not worry too much about it. So what are these numbers I'm calculating? See, while choosing factors, my factors can be either 1, 2 power 1 or 2 power 2. Correct? Only 3 cases.
Yeah.
Yeah. Similarly, for 5 square, it can be 1, 5 or 5 square. Correct. So can you see that I'm choosing one among these? So that's 3 into 3. Right?
Yes.
Can you repeat what he said?
That's how we are getting the calculation. So if you want me to write the theorem, it's nothing but suppose your number, let me change this to some other color. Suppose your number is nothing but say P1 into P2 into P3. These are all prime factors, right? You always write in primes. If you write in any number is composite, your method will fail. Okay. So even though it's a simple number, like stricter calculations will be wrong. You have to write it in terms of 2 power. Okay. So into Pn, all these will raised to different powers, alpha 1, alpha 2, alpha 3, so on. Right. So this is alpha. So the number of factors, what is it equal to?
Alpha 1 plus 1 times alpha 2 plus 1 times alpha 2 plus 1 all the way till alpha n plus 1.
Exactly. Sorry, plus 1, right? I wrote plus 2 here. Yes. So this is plus 1, alpha 3 plus 1 into, will continue up to alpha n plus 1. That's it. What I told you, I just wrote down as a statement. That's all, right? So it doesn't matter how many powers are there. All I add 1 and multiply them, right? So that will be your formula for it. Okay. And one more thing before I start off with the problems, divisibility test. Okay. I usually don't do that, but I heard that you people are very good at it. So let's see. How do I check for the divisibility of 2?
If
If
it's
it's
even.
even.
The digit should be the multiple of 2, like 2, 4, 6, 8, and
It can
0.
be 0, 2, 4, 6,
In small numbers, in small words, it should be an even number.
Yeah. In simple words, it should be an even number, right? That's all. See, we all know, see, when I'm talking about divisibility, obviously that number should divide that number, right? That means divisibility. Now, what are these divisibility tests? Instead of dividing, is there any technique? Is there any technique so that I can directly say it is divisible by 2? That's all. So simplest way for the number 2 is, if the number is even or odd, even it divides, odd it doesn't divide or leaves a remainder 1. Okay. So one more, 2 divides 6, right? We can write it in this form also, right? Correct. This means A divides B. Okay. You usually write 6 divided by 2, something like this, right? So I don't want any confusion. Okay. So sometimes they write this. I don't know if they will give you in NMTC papers, but later on, at least for your other Olympiads, this is involved. Okay. Anyways, let's not confuse. What about the next number 3? What should I do?
If the sum of the digits adds up to any
The sum of the digits should be
Sum
equal
of the
to,
digits
it should be the multiple of
the
3.
number is
Sum of the digits, right? The sum of the digits is divisible by 3, or 3 divides the sum of the digits, then it is divisible by 3. Okay, great. What about number 4?
if the last two digits
Last two
are
digits is divisible by 4.
Okay. If the last 2 digits is divisible by 4, right, then the entire number is divisible by 4. I need, however long the number might be, I just have to check for the last 2 digits. Okay. What about number 5?
if it ends
0
with a
or
5.
5.
Ends with
The
0 or 5.
last digit should be 0 or 5.
What about 6?
If it is divisible by 2 and 3.
Yes. Now, can you see this 6 is a composite number, right? So if it is divisible by 2 and 3, then the number will be divisible by 6. Right?
Yes.
So easiest way to check that is check the divisibility of 2 and 3. So you'll get 6. Okay. What about 7?
There is a method, but it's not very efficient.
Okay. So that's correct. So if you have to check for the divisibility of 7, we simply divide by 7 and check. So the method will take more time than this. So it's always better to directly divide by 7 and check. Okay. What about number 8? Number 8.
The last three.
Last 3 digits.
divisible.
3 digits. Okay. Last 3 digits. If it's divisible by 8, the number is divisible by 8. Okay. What about 9?
It's the sum of the digits. It's divisible by 9. It should
Yes,
be
sum of the digits. Now instead of 3, for 3 it should be divisible by 3. For 9 it should be divisible by 9. That's all. Right? Okay. 10, I think 10
should end with a 0.
ends with 0. And 11, I think we can stop here at 11. Yes, what about 11?
Yeah. 11. The difference of the sum of the odd digits and the sum of the even digits should be a multiple of 11.
Okay. So for example, if it is 1, 3, 3, 1, what should I do?
You have to take the first
Sum of the even places and odd places. Okay.
Yes.
So let me see even places first. So 3 and 1, 3 plus 1, sum of even places minus odd places 1 plus 3. This is equal to 0 now. Is this a multiple or not?
It is.
Multiple.
It is. The final result should be
11.
0 or a multiple of 11.
Okay,
11
0 is
into
a
0.
multiple of 11. Yeah, okay. So 0 or a multiple of 11, fine. 0 can be considered a multiple of 11 anyways because we can multiply that.
7 into 0.
So is 0.
Yes. Okay. So you know all the divisibility up to 11 also. It's great. Fine. I think that's it. Anything extra we want, we'll learn during while taking up the problems, right? So let's see. Try the first problem. If you get the answer now, from now you have to put the answer in the chat. Okay. Just because I don't want others who are solving chat. Okay. Those who joined us on YouTube, you can just find the link. Right. Most of the students are on Zoom itself. Okay, you're getting different answers. Still a couple of minutes, you can try and see. Okay. A lot of you have given the answer right now. Okay. So let us try to find what this is first. 8 4 by 9. Correct. It's easier to convert this into an improper fraction, right? What is it? 8 into 9, which is what? 72. Okay, 72 plus
yeah.
4, 76.
76.
76 by 9. Fine. So I want to check in the options which of these is greater than this. If only one is right, it's fine. Usually it's only one right, but still I want to cross check. So I'll write all of them down. So 8 into 3 plus 1, 25 by 3. Now is 25 by 3 greater or smaller?
Sir, multiply the denominator so that it reaches 9. So 3 3
Like 75 by 9.
25 by 3 and you get 75. 75 by 9 is obviously smaller than 76 by 9. So option A is not the answer.
So always make sure you make at least one of the components same. Numerator is also okay. It's not that you have to make the denominator okay. Usually what happens is it's easier to make the denominator equal. Therefore we do it. Now, if I simply compare, if I divide, it doesn't make any sense. It will take a lot of time. So if you multiply the numerator and denominator with 3, we're going to get 75 and 9. Now clearly this is less than that. Right? Okay. So similarly, you can continue. Here we can divide by 2. So this is 9.
Yes.
Numerator is 75 again. Correct. Again less. Okay.
Yes.
What about next? 8 into 3. 24. 26 by 3. If I multiply with 3 now, it's 9. And this is what?
8 by 9.
Yes. This is 78, right? So it's greater. So option C looks fine. Let's just check option D, just in case. So I can divide by 3, I guess, right?
Yes.
Numerator is 73, again less. So option C is correct.
Why is it 73?
Isn't it? Sorry, 72, right?
Yes.
Yes, 72. Calculation errors, right? Okay. Next. Because there are 2 classes involved, 7th and 8th. Some of you might find it difficult, some of you might find it easy. The paper also will be, again, similar, right? Obviously, the 8th standard students will have an advantage. Right? But next year, when the students in 7th go to 8th, right? You people will get the advantage. So.
Sir, I solved it.
Yeah, okay. Just put in the chat, it's fine. Okay, only 3 of you have answered. This might be a new problem for the majority of you. Yes, yes. This is a very unique problem, and right. So let's see. Let's see. What we do for this is, see, all these terms are consecutive numbers. See what I'm doing. I'm writing the numerator, right? 1 as the difference of the negative numbers. So always I can write 1 as, I can write as 2 minus 1, 3 minus 2, 4 minus 3, so on. Right? No issue. This is 3. Okay. What will be the last number? Again, 1 can be written as n plus 1 minus n divided by n into n plus 1. This is fine. Now I'll simply divide. So it will be what? 2 divided by 2 is 1 minus 1 by 2. I'm dividing each of the numbers. Okay. 3 divided by 2 into 3. So it's 1 by 2 minus 1 by 3. Can you see that? Next is what? 1 by 3 plus 1 by 4. Can you guess the next one? Sorry, it's minus. So it's minus 1 by 4. Next is 1 by 4. Right.
Minus 1 by 5.
Minus 1 by 5. Can you tell me what will be the last term? Last term then. Can you see here? If I divide, this will get cancelled first. So
1
it
by
will
n
be
minus.
1 by n. Next minus 1 by n plus 1. Is it fine?
Yes.
Can you see what is the advantage of writing like this?
Yes. Most of the terms cancel.
Most of the terms get cancelled, right? So you can see that these two get cancelled, these gets cancelled.
Sir, how did you write it like this?
How did I write it? This is a numerator, right?
Yes, sir.
So I divided this to this, right? So it will be 2 by 2, correct? It's 1.
Yes, sir.
Next I divided it to the other term, right? So it is 1 by 2. So it's basically split it.
Oh, okay, sir.
So now again, if you divide like this, you can see that 3 and 3 will cancel. It's 1 by 2, right? For the other part, 2 and 2 will get cancelled. It's 1 by 3. Is it okay?
Yes, sir.
Okay. So what are the terms that remain? So you can see that there are only 2 terms remaining. 1 and last term, which is minus of 1 by n plus 1.
Yes.
This is equal to 19 by 20. If you want, you can rearrange them. 1 minus 19 by 20 is equal to 1 by n plus 1. Or 1 by 20 is equal to 1 by n plus 1. This implies n plus 1 is 20 or n is 90.
Yes.
Yes. So, see, these kind of problems will be very common in high school and later classes. Okay. So, whenever there is some link like that, right? So, nobody expects you to sit and calculate all these numbers. It's not possible. Okay. The majority of these problems can be split into 2 terms, and the terms will keep on getting cancelled.
Yes.
Okay. So, make sure whenever you see such kind of problem, first to look out for these. Okay. Next problem.
Sir, once can I go to the previous slide?
Yes.
Yes, sir.
Sir, could you go to this second, like the before slide for 1 second?
First slide, we let the students
No.
write the question down first. Then I'll go back.
No.
Let them start trying. Then we'll go back and. I hope everybody has noted down. Yeah. Which question you wanted? First question.
The second one, sir.
Second one.
Thank you, sir.
Tipos muy lindos y vivos muy niños, ricos es de lo que quiero. Habla muy bien y portarme muy mal, eres un caballero.
Sir, there is some disturbance.
Yeah, somebody had joined. I just removed them. Somebody creating some noise. I just kicked them. Okay, we'll give you a couple of minutes to solve this one. So answered are right, so do not worry. Just put your answers. I'm not going to cross-check everyone. While we discuss, you'll come to know anyways. Okay. There's a simple trick, right? For this, I think easily you could figure out what the answer is. Yes, Anudeep.
What, sir?
Did you get the answer?
No, sir.
Okay. What about Yukta?
No, sir.
Okay. Can you think of any trick here? Because
Sir?
yes.
Sir, I think B is 3. I did not get A.
Siddharth, sorry, I couldn't follow.
Yeah, I think B is 3, but I did not get A.
You think B is 3, you did not get A. Okay. My concern here is, can you see this part here? This 2018, right? This does this tell you something? What the option should be?
So the option should be divisible by 2018.
Yes, correct. It should be divisible by 2018, right? Don't you think so?
Yes.
Yes, sir.
Yes. So that really solves your problem, I think. I don't know. I didn't check the options. I didn't check for divisibility. But because the options are, the difference is not more than 2000, right? Certainly only one of the options will divide, I think.
Sir, is it C?
I don't know the answer. We'll try to solve it and we'll figure out. No, I'm just giving you some examples, right? So in this problem, without even solving, without even checking A and B, I think you can get directly your answer by simply dividing by 2018. So always look at the problem, right? What it asks. If you can solve it in a different way, it's always welcome. Okay, let's see.
Sir, what if there is so many options which are divisible by?
Now we'll see the actual method how to go about.
Sir, I did by using that quadratic
So you try to solve this quadratic equation. Okay. You're in 8th or 9th? You're 8th or 9th, Anudeep?
8th, sir.
8th. Okay. So you know. What about 7 students? Do you know quadratic
I know.
equation?
But we can use perfect square identity, sir.
Yes, yes.
We can use perfect square identity to solve the question.
Yeah, yeah. But still, again, 7th and other students in 7th, right? Do you have any idea how to solve this?
Yes.
Other students? No, nobody answered. If it's no, tell no so that I can help you out. Right. If you don't reply, probably no, right? Okay, okay, don't worry. So you know how to multiply these at least, right? We don't know how to solve it, but can you see? Okay, let's see for b square. Somebody had got Siddharth. You had got b square, correct?
Yes.
How did you get it? How did you get it?
So I assume like 2 square is equal to 2 into 2 plus 3. I did not get the answer.
2 square.
I did not get LHS is equal to RHS.
Okay, okay, okay.
So
Then
it next tried on 3. So I got
Okay.
LHS is equal to RHS.
Okay. Then you stop there.
Yeah.
Okay. That is actually somewhere right. Okay. See what is happening. See what is happening. See, on the one side you have a square. Correct. You're talking about only natural numbers, so it's not that difficult for this. One side you have a square, other side you have a linear term, right? This is called a linear term. If the power is 1, it's called a linear term. Okay. You know that square increases pretty quickly, right? The other side, suppose this is 10. This will be what? 10 square. On the other side, it will be only 2 into 10 plus 3. Right? So can you see what is happening? This is what? How much is this? 4 plus 3. This is 7. The next number is what? 3 plus 6 is 9. Next number will be 11. Can you see that? Here, what is it? This number was 4. This is 9. Next number will be 16. Correct?
So we are supposed to solve this using trial and error method.
Next number will be 16. So you can see that b equal to 3. Okay. Just because you don't have the knowledge of quadratic equation, this is how I'm solving. Okay. There's a direct method. Yes, Varshini.
Sir, so we are supposed to solve this using trial and error method.
Yeah. For now, yes. There's a method. There's a method to find out. If you know, learn later.
Sir.
If you don't know, this is the easiest way, right?
Yes.
Trial and error. It's not exactly. See, you're using this in a proper way.
Yes, sir.
Right. I'm saying that this is increasing very fast. It can be equal. They can be equal at 3. Then after that, they never can be equal. Right? We can see that, right?
What about A, sir? How do we find out A?
Okay, A will see. Now these numbers are huge, right? It's a little bit tricky, correct? But can we divide by 3? Can you see that 3 is common? So if I divide by 3, what is this? This is 32. Is it fine? Now we'll check with the smallest natural number, which is 1. So this side is 3. The other side is 4 into 1. It's 36. Fine? Certainly not equal. When I put A equal to 2, this is 2 square into 3. This is 4 into 3. It's 12. On the other side, I have 8 plus this. This is 40. You can see on the right hand side, it's increasing very slowly, right? A linear function. Next, you can guess what it is. It's 44. It's 48. It increases by 4. Why does it increase by 4? Because this, when I take it from 1 to 2, this will be from 4 to 8. The number is constant, right? Therefore, it will increase by only 4, right? So it is easy to see. You need not even calculate. On the other side, it's square, right? Okay. It was 1 into 3. Next is 4 into 3. Next is 9 into 3.
9 into 3, yeah.
27. Next, 16 into 3. Is it 48? Is it equal? Did we get our answer? A equal to 4?
Yes, sir.
A is 4 and B is 3. This is what we got. So your answer is 2018 into 7. I think you'll get C, if I'm not wrong, right? Okay. So if you want to continue here for A, on the other side, it will be 52 itself. Here, it will increase quite a lot. Okay, so for the higher numbers, it's certainly not equal. Both sides won't be equal. So I have to write this like this actually, right? It's equal only at 48. So other numbers, it's not equal, right? So that's how it is. So it's not equal. Okay. Is the method clear? Don't worry. For the next year, probably those are in 7. Or you will learn quadratic equations, and you will solve it in a different way. Okay. For now, this is the simplest way I can teach you. It's fine.
Can you show an example with quadratic equation?
Example. Okay. So this is the same example I'll take. Fine. How to solve this? What we do is we write this as b square. Let me just erase here this one. Okay. So b square. Remember, I'll keep this as it is. Okay. So this last term, what is there? Constant term is -3. Correct. I'll split this into 2 factors, such that the sum is -2, right?
Then the product is -3.
Product should be -3 and the sum should be -2.
-3 and 1.
Okay, got it. Thank you.
Got it, right? So now can you see that if I split it like this, so it is -3b plus b. So here b is common, b -3 and b -3 is still same. So here 1 into b -3. So the 2 factors are b plus 1 into b -3. So there are actually 2 answers for this equation. One is b is equal to -1 and b is equal to 3. So both are your answers. But it's given that it's natural numbers. Therefore, we're getting only one answer. Okay. So this you'll learn in the higher classes. So do not worry about it right now. Right? So this is the other method. Okay.
Thank you.
Next. The number of 3-digit numbers which contain 6 and 7.
So both 6 and 7 it should contain, right?
Which contain 6 and 7. Oh.
Should it contain either 6 and 7 or both 6 and 7, sir?
It is given and, right? So both, we'll consider both, right?
I know it's hard to remember the people we used to be. It's even harder to remember.
Some people are joining this. Okay. Some people are trying to join the webinar, so that's why the disturbance. Yes, we were discussing 6 and 7, right? So
Yes, sir. And my doubt was if we have to consider both 6 and 7 or
when there is and, we consider both. When there is and, we consider. If they are given which contains 6 or 7, right? Or 7, we'll consider either of them.
if they're given or 7, then can the number have both 6 and 7?
Yes, yes. Either 6 or 7. Even if both are there, we have to calculate.
Sir?
Yes, yes, Vishal.
Sir, so both the numbers should be in the 3-digit number. Like, no, one number should not be
I
excluded.
couldn't hear you after that. What? Sorry, I couldn't hear you.
Sir, in the 3-digit...
Ishan, can you repeat your doubt?
Sir, in the 3-digit number, both 6 and 7 should be there.
Am I getting disconnected? I just heard 3-digit number, that's all.
Sir, I'll type in chat.
So, like even I have that doubt. Is it both 6 and 7, or like 6 is 670 counted, or like I mean if is 600 counted since it contains only 6?
No, it's and, right? That's what I just clarified, right? See, when you have, when they ask you and 6 and 7, both should be there. If the problem was 6 or 7, what happens? 600 can be counted, 700 can be counted. Now you can count 670. Is it fine? And means both have to be there. No option. If it's or, either of them can be there or both of them can be there, right? Just a minute. Okay. So what will happen here? It's something like if you have seen Venn diagrams, right? A and B, correct? What do you mean by and?
Yes.
And means this is the intersection part, right? Which both of them are there, correct?
Yes.
When it or, it can be either single A or single B or both of them. So either way it is possible. Okay. Yeah, those answered are right. So let others try to solve. Again, you have a class at 6 o'clock. I hope you guys know this, right?
Yes.
Sir, I got disconnected, sir. My doubt was if like they have written which contains 6 and 7, if it was 6 or 7, then should it have both 6 and 7 or only either 6 or either 7?
That's what I explained. I think you got disconnected. See,
Yes,
you
sir.
know Venn diagrams, right? Have you seen this Venn diagrams?
Yes, sir. Yes, sir.
So when you say and, you're talking about the intersection here, right? Intersection, correct?
Yes, sir.
Only which is present in both A and B, correct?
Yes.
When you're talking about or, you're considering the entire part, right? Even the region which has the common part. That's what or means. Or A union B, correct?
Yes, sir.
So similarly, you have to consider a number which contains both if it's or.
Yes, sir. Is there like a formula or something to find out questions like these?
No, you just have to write couple of examples, right? Write couple of examples, then figure out how to count. So these are all problems of counting. So you write a couple of examples. You see, okay, these are the numbers possible. So how many such numbers are there? You are trying to count. So there you have to find some trick to calculate it quicker. Not write down all the numbers, right? Let's try this. We'll figure out. Okay. Yes, sir. Can you give me some examples which is true? Contained, it should be a 3-digit number. And
176, 167.
670, 767, 676, 766.
okay.
670 to
Only a couple of
670.
examples. You don't want all the numbers.
167, 267, 367, 467, 567, 667, 7.
Yeah, enough. Got it. So whole idea is simplest number is 167 or 176. Okay. I was just trying to figure out. There are once you learn more counting problems, it will be easier to calculate. But right now we are figuring it out, right? So I just want to know how many such numbers are there. Can you tell me how many such numbers are there which ends with 67? Ends with 67.
9. In the
9.
same way, 76, like with 76 also it will be 9. So
Okay, 9 numbers here. And 9 numbers ends with 76. Everybody agrees with this.
Yes.
Correct. How many numbers starts with 67?
Only one. I mean,
only one.
Like which will satisfy.
Is it? Okay.
9, I think so.
Sorry,
There are
9.
9. Anybody who disagrees?
Yes, sir. 670 to 679.
Yeah, how many numbers?
9, sir.
It's 10, sir, 10.
10 it is, not 9, 10 numbers. See, what is the difference between this number and this number? Here, okay, whenever I go up, this is a problem. So, it can start from 670, right? In this case, you can't have 0 as your first number. If first number is 0, it will be a 2-digit number. Okay, fine.
Yes.
Okay, so you're saying there are 10 numbers here, and starting with 76 is also 10 numbers again. Fine, agree. Now, one other case is what? Between 6 and ending with 7. How many numbers?
10.
0, 1.
Again,
Yes,
10 numbers. Starting with 7, ending with 6. 10
There are
numbers.
10.
What are total numbers?
Total numbers which contain 6 and 7, sir.
52.
Yes. Yeah, none of the options.
Yeah, 52.
Is it 52?
It's not.
How much
Sir,
numbers?
I have got 60.
No, sir.
You got 6. No, how much did we get?
58.
We got 58, right?
Yes.
Yeah. What is
There are some numbers which are repeating in each case.
missing in ours? What is missing, or what have we calculated wrong?
677 and 776.
6, 7, 7 and 7. Okay. Let me see. 6, 7, 7.
We have 4 sets, sir. 677, 776, 766, 667.
Yeah. But first tell me why 6, 7, 7. What is wrong about it, Varshini?
It's counted twice in the
Counted twice,
67 counting and 670 counting.
So 677. See, this is your. This is what you have to be careful about, right? Calculating simply by plugging in numbers, everybody will give the answer, right? Here you have to take these cases seriously, right? You have to check if something is getting repeated, something you have counted more number of times, right? Somewhere in 2 of the categories now, the same number is calculated, correct? You can see by changing this number, it was 677 I used to get, and the same number is repeated here. So I have to subtract that, correct? What other numbers should I subtract?
Same stuff with that.
Same stuff on the other side. So 776 you should subtract.
Okay.
766.
That's it? 2 numbers? Done?
Yes.
Sure?
No, not only those. There are others.
Yeah, that's what I'm asking. What are the others?
76.
Yes. 6?
676.
676, correct? Then?
And 767.
767, correct? Then?
667.
667.
776.
That's it?
No, there should be 2 more.
2 more? No, there are only 6 possibilities.
1, 2, 3, 4, 5. Oh yeah, we completed 6 already. Yeah. So it's 52.
Your answer is 52.
Yes.
Did others understand why are we removing this? See, I calculated 677 here. We're just counting the numbers, right? We're just counting the numbers. If I count the same number twice, the count we have made a mistake in the count, right? Can you see that? So I'm counting 677 here. I'm counting 677 here. That's not possible. The same number, how I can't count twice. That would be wrong. Right? I hope you are able to follow. If there is any doubt, you ask me. It's any of time, right? We can stop here. I'll calculate this. We'll continue with the problems again, directly with problems in the evening session. I'm going to take the evening session again. It's from 6 to 7:30, right?
Yes. In the photo which is sent for us, it's there 6 to 7:30. In the message which is sent, it's there.
It is
some other time, not 6 to 7.
You just got the message or you got it yesterday?
It's there 4 onwards, sir. Like I got it today itself.
I think 4 onwards.
That's 9 to 10.
9th to 10th.
Yeah,
is-
that's for 9th and 10th.
Yeah.
It's there free class 7-8 session 3 time February 28 4 p.m. India.
Okay, I'm just confirming. Don't worry. It's at 6 because I'm going to take the class itself, right?
It's
So
at 6. Okay, sir.
Yeah, it's at 6. Okay. At 4 o'clock, if any of your, I think, brothers or sister, 9th and 10th, they can attend. That session is at 4 o'clock. This is at 6. Yeah. Okay. If no other doubts, I think we can end the session here. Or if you want to clarify something, we can do that. Or we'll end the session here. We'll continue with this problem set in the evening.
Sir.
Yes, sir.
Okay. Okay. No doubts. Then thank you guys. I'll end this session here. Right?
Thank you, sir. Bye, sir.
Bye.
Thank you, sir.
Bye, sir.
Bye, sir.
Thank you, sir.
Thank you, sir. Bye, sir.
Thank you, sir.
Thank you, sir.
Thank
Bye.
you, sir.